Why do partitions matter from a consumer group perspective, though? We've already talked a bit how partitions balance across consumer IDs, but let's look at a more specific use case. Our use case is that we have two distinct applications. And with that first applications, we're running two instances of it. That means that there are two application instances running, each sharing the same consumer group ID. So what happens is that means that the consumer group ID being the same across both instances will split the number of partitions. Because I'm using an uneven number of partitions, it's going to mean that one instance 1, is going to be connected, for example, to partition 0 and 1, while the second instance is only connected to partition 2. That means that if an event goes onto the user topic and then hits partition 0, only applications 1's first instance is going to pick that up. And if the event ends up on the second partition, instance 2 will pick that up. But in most cases, consider that you're going to have multiple applications, multiple consumer group IDs listening to the same topic. In the case of application 2, it's only one instance. So when it starts up, it's going to connect to all 3 partitions. So any event going to any partition will be picked up by that second application because it's only one instance. The way that a technology like Kafka keeps track of where a consumer is using something known as the consumer group offset. So consider in our example, we essentially have two consumer groups. Consumer group 1, which is shared for the instances of application 1, and then we have consumer group 2, which is the consumer group for that second application. So the topic itself is going to have some number of events in it at a given time. So at time 1, let's say topic A has 10 events in it. What that means, though, is that each consumer group is capable of listening to topic A and maintains its own offset. For example, if consumer group 2 is always on, it's technically going to be a little bit behind on the event stream. For example, if it's running as fast as it's canned, it may be 3 events behind in the actual topic, and this is why it's called the consumer group offset. But consider that in consumer group 1, if the application shuts down and it's not running, that consumer group offset can run. This is important to note because this means that each individual consumer group has a position in the event stream that is going to be some difference from what's actually in the topic. From a monitoring perspective, it's important to keep track of this because if your application is having to do some amount of processing, it can be possible for a consumer group to get impossibly behind. For example, if you see that offset start to just increase and never be able to catch back up and not hold at a steady pace, this is an indication that your method of consumer group and partition strategy is not able to keep up with the actual event stream. This is an indication of needing either more instances or a different type of partitioning strategy to be able for that consumer group to be able to keep up with the events going on to the topic.